Hello everyone, it's Richard here. In this video we're going to be following on from the initial setup and build of the TAZ6. Now in this video I wanted to go over some of the problems I had getting the printer up and running. They weren't very big, but they are just some things that you might find on your TAZ6 printer if you get it shipped to you, or on another printer that has similar electronics. So I wanted to go over it. That was a little bit in the past, so we've jumped ahead just to do this introduction bit, and that's because I just wanted to go over, catch you up with really where I'm at with the TAZ6 and 3D printing with it in general. So we'll be going on to that in a minute, but I just want to say first of all, big thank you to LulzBot for sending me through a MOARstruder. Now this is something I mentioned in the first video and something I really wanted to play around with. So they've actually sent me through a MOARstruder, which has got the great big printing nozzle on and has basically a lot of capacity. So a 1.2mm nozzle. Comes in a wonderful box, all lovely retail packaged, which we've got here. And on here we've got bigger, faster, stronger, more. 3D printing up to 100 grams per hour. I think we can increase that more than 100 grams. That's going to be my challenge. All of these things are going to be my challenge. So layer heights from 0.3 to 1.2. Now I reckon you can go lower layer heights than that. I've done 0.1mm layer heights with a 1.2mm nozzle. So again, I'm going to prove that wrong as well and try and do that. Max printing temperature 300 degrees. Well, that's fair enough. Yeah, I don't think I'll be going over 300 degrees. Compatible with many different fused filament fabrication materials. So yes, we'll be testing it on all sorts of different materials. It comes with some Tolman tea glass, which is going to look absolutely gorgeous when it's printed, and I'll be printing as many other things as I can. Also, the team from LulzBot sent me a massive roll of Polymaker filament. Now, it came in a great big box, well, not that big I suppose, but bigger than you would expect. And it's the biggest roll of filament I've currently yet ever seen. So this is Polymaker's 3 kilogram roll of filament. 3 kilogram. Now I didn't even know Polymaker made 3 kilogram rolls of filament. This thing is huge. If we take a 1 kilogram roll, which is like a normal roll, and this one's, you know, most rolls now maybe be 750 grams or 1 kilogram. So size of difference here, you can't really tell, but it is huge, and it's obviously 3 kilograms in weight. So this is really big, and that's going to be great for testing out the MOARstruder, because I have a feeling the MOARstruder is going to take a lot more filament to actually go through. So it's going to be a real gobbler of filament. Now the other thing you can probably see in the background as well is the other extruder I've got on there, and again this is a big thank you to Colorfabb. I was doing some upgrades on the TAZ6, and I've got one hidden behind here because I don't want you to see it yet. That's coming up in a future video. I'll show you that soon, don't worry. But I did want to produce a extruder upgrade for the Titan AERO, the E3D new little extruder. And Colorfabb actually sent me through a roll of special LulzBot material. Now this is not available on the website because it's manufactured just for LulzBot, so a little bit of a surprise getting this sent to me, and really want to just thank Colorfabb. They also sent through a wonderful box of samples, which I really appreciate, and a whole load of stickers, including a whole load of LulzBot stickers, which will go on my machine and my computer and everywhere else, and of course a whole load of nGen samples, which is really nice because I love that material. So thanks ever so much Colorfabb, and I have done some really cool stuff already with it, and behind here that you'll see soon. Okay, so that gives you a little bit of an idea of where I'm at. We're a few weeks ahead from the video you're about to see, which was really the setting up in the early days. In fact, a couple of months ago that was. There was a lot of printing at Christmas, during Christmas, and all sorts of things, and getting set up. Also, I will show you some prints that I've been doing that tweaked a lot of the settings in both Cura and the slicing settings, as well as the firmware settings that I'm going to be changing on the 3D printer here as well. So I have changed some of those, and something you may want to do. I wanted just a little bit more performance out of the TAZ6. You don't necessarily have to do it, and of course the LulzBot team run a massive farm of these things with all their settings as per normal. So it's up to you whether or not you want to take my advice on tweaking and enhancing your LulzBot Taz6. So I've got the Titan extruder now fitted and working, and I'm just playing around with tweaking some of the settings on that. It's a early example of the mounting system. I'm really not very happy with the fan on there, but it does give you some idea of how it will actually sort of work when it's finished. It's all set up and it works quite well, and it's actually got the electrical sensing system. On all of the LulzBot machines, they have an electrical wire connection onto the hot end, and that actually makes an electrical connection onto these 4 pads on the corners here to level the bed. The Titan AERO is about 178 grams less weight than the normal extruder, so you can throw it around a little bit faster. So that's a good option. And I've actually got the E3D Volcano nozzle on here as well, with a 0.6. So we've got 0.5 on the original Taz extruder, 0.6 on the Titan AERO, and a 1.2 on the big MOARstruder. So that's going to be really interesting to see the differences there. But I think I can get quite a decent capacity out of this. There's a little bit of a hack out to create a little wiring loom for that. It's only temporary, I'm going to change that anyway. But at least it got it up and running. Now, while we're on the subject of bed leveling, there's just one more thing I don't think I talk about in the next video, so I just wanted to go over it here. With mesh bed leveling in Marlin, what it does, it probes the bed and it works out whether it's level in the X and Y axis. And as it's moving around, as your print head is moving around, the Z axis is moving up and down to compensate for the fact that it's not completely level. Now, if you just take the TAZ6 out of the box and just plug it in, it will compensate and it will move around and move the Z axis up and down as it moves around the bed. Now, there's nothing particularly wrong with that, apart from it takes time for when your head is traveling across the bed and the Z axis is moving up and down. And the Z axis is the slowest axis. So my advice, when you get your TAZ6 or any other machine that uses mesh bed leveling, is to manually adjust as much as you possibly can to make the bed manually level as possible. Level, true, and vertically straight. So those are the key things you want to be doing there. You're tramming the bed basically to try and make everything as flat and level as possible. You can do that quite easily by measuring the left and right Z-axis screws. So you want the same sort of distance between the bottom of the screw and where the screw mount is connected onto the threaded side. So measuring that distance on the left and right and just evening those up will help you get a level bed and a level extruder on top of the bed. Then if you move the extruder around manually, just gently, and you move the bed around and you put like a known distance under there, sort of a sheet of paper or something, you can gauge the distance between those. When you move everything around, you'll see whether or not the extruder is diving down on one side or at the front or at the back, and then you know to adjust as much as you possibly can. But that's really just my advice, to try and get that as level as possible, because it means then in the firmware it's not doing as much compensation and you can get a little bit better performance, a little bit better speed, and also a little bit better print quality, if I'm honest. So don't disable mesh leveling, because it is really great, but try and make it move as little as possible from left to right. You don't want those lead screws having to move too much up and down. Anyway, that's my main point there. Hopefully that'll make a little bit more sense when we get into the printing and some of the tweaks I've done to the accelerations and the firmware settings, which mean that this machine is now a real beast. So we'll see how we get on with the Titan AERO, see how we get on with the MOARstruder, and they'll be in a future video. There'll be another one after this explaining all the things I've printed, but this one is really to go over some of the initial setup issues I had with the 3D printer. So hope you enjoy it and join me next time. So we're moving on to the TAZ6 operation now. Switching it on. It's a nice operational guide. It comes with an 8 gig SD card, which I'm going to put into the machine. Okay, card inserted. Oh, that's interesting. It says no SD card. Okay. So it looks like you don't get any G-code on the card, which is a bit annoying. It would have been nice to come with maybe the Octopus G-code,
should be able to do that and distribute it. So I'm going to have to set up all of Cura and get some G-code onto this SD card so I can do a quick test print. Okay, so I had a look at the files on the SD card that came with the TAZ6, and indeed there are some G-code files in there which I should have been able to see on the LCD when I put it in. So there's likely to be a problem here, because when I put the SD card into the slot on the side and powered it up, what I was seeing was that the card was being recognised, but the files were not showing up. So that's a telltale sign that there's a bit of a problem either with the SD card or with the interface. So I started to investigate, and I thought I would just let you see what was going on, because I'm just about to take out the last few screws. While we're doing that, I'll have a little comment about what's inside. So just got a couple more screws to go. I also tried a different SD card in there as well. Copy the G-code files over to that and put it in, because sometimes these are Arduino based boards and can have a little bit of a hard time reading some types of SD cards if they don't have the right SPI style interface. So that didn't work either. So I'm just about to, let's just turn this one off. Now remove that card and just get this last screw, the last couple of screws out of here, and we'll see what's going on. Okay, so first thing, oh that's nice. So the first thing you notice having a look inside is already that the box, it's a nice screen box. So we've got this, where all the powder coating is on, we've got this surface which touches onto the metal surface on here, creating basically a sealed box for EMC not to leak out. And that's another indication that, again, some thought has been put into how this product is going to be approved and tested and verified to be safe and meet FCC compliance and EMC compliance around the world, which is quite nice. At the bottom as well, the power inlet, which I will just unplug. At the power inlet, you've got the mains coming in. There's a mains filter in the bottom here. I will take a quick photo for you to see. And this mains filter has also got a ferrite clamp on as well, and that really helps with conducted emissions. Now, conducted emissions are what a 3D printer or a washing machine or whatever else puts back down into the mains and is picked up on your TV or whatever, or other types of appliances. So it's quite important that these types of devices are fitted to certain, you'll see them on things like vacuum cleaners because they've got big motors, and that doesn't want to be injecting noise back down into the mains and being picked up on your TV or your other devices. So it's quite important. That's called conducted emissions that they test for. So again, it's another good sign that this has gone through quite a lot of testing. There's some ferrite clamps on a lot of the other cables again, so that's for radiated emissions. Basically every wire you've got inside this 3D printer is an aerial, so that actually causes some problems radiating out, and again interference can be picked up on other devices and also picked up on this device. So it's designed, these sort of things are designed to check, and these approvals regulations are designed to check that the device doesn't emit too much electrical interference and doesn't, when it receives electrical interference, doesn't go wrong. So the reason why I opened it up though was to have a quick look around inside, and I can see the Rambo board in there, and I'm familiar with the Rambo board, but what I wanted to check, because I was a bit suspicious about this, the card interface, the SD card interface on here, detects that the card's been put in, because there's a little switch that it says, yep, the card's been put in, and it actually could see that on the screen. When I was powering it on, I could see that it could detect the card was being powered up, but because it couldn't read it, I was wondering whether or not there was any problems with the cabling. And actually, oh yeah, I can actually see, that's interesting. So yeah, here we go, there is actually a connector in there that's come loose, and that looks like the problem. So we've got the spare connectors on the Rambo board being split off to go to the SD card connection up here, and we've got one 10-way ribbon cable and we've got another one, and it looks like what's happened is that's just pulled off. So I'm going to push that back on. generally this is a bit of an issue with these types of connectors that don't positively lock. And I really don't like any connectors that just sit there and can just fall off. If they haven't got any positive locking, then they're likely to fall off in transport. And that's exactly what happened with this by the looks of things, which is a bit of a pain really. If I'd have been a normal user that didn't want to open the side of this machine up, then I might have been a little bit worried about pushing connectors and things back in. So it's something to always think about. Some of the other connectors are positive locking, the little two ways and things. I can pull on them and they are actually in there and they've got positive locks. So again, that's a really good sign. And more of these connectors really should be used. So I always try and tend to use positive locking connectors on any electronics that I make. And unfortunately, just because of the way that this one's had to be wired to get the pinouts for the LCD interface and the SD card interface, the little box headers on there are they're just pins. So they're just gonna sit there. There's one down the bottom as well, which has got only 2 pins connected. But what they've done is they've put all the other crimp pins in, and that's a little trick to aid a little bit more friction. Otherwise, if you've only got 2 wires coming off of a 10-way connector, it can often fall off. So they've gone to the trouble to put extra crimp pins onto that connector, which is quite nice. But the one that actually fell off was just above it, and that's got that's got 4 wires. Yeah, about 4 wires. Yeah, it is 4 wires coming off, and that looks like it's just fallen off in transport. They aren't particularly tight or pulled, so I'm not quite sure why that happened. But I think that will solve our problem with our SD card interface. So before I put the connector back on, before I put the cover back on, let's just check that. And I did unplug the mains, so let's plug that back in. Okay, so we're powering up. Got MacLeod on there. LulzBot Taz6 ready, so I put this on the side. And it said card inserted, so hopefully now I will be able to see print from SD. Yeah, I can see all of my directory structure and the G-code that I put on there to test. So I'll screw this all back together and we'll give it a check with. So we're all screwed back together now. Make sure these are done up nice and tight to make that mechanical and electrical seal on the box. And we're ready to go. So I'm going to test with some G-code, some standard G-code that came supplied. I've already loaded on some Colorfabb nGen into there, and the G-code's been pre-sliced, ready for using with nGen. And hopefully this will show up if there's any other problems. I'm going to double check with LulzBot about that issue to see if anyone else has had connectors falling off of the Rambo board. So we've got 1 hour and 50 minutes later, we have our finished Benchy. That's pretty good. That's not particularly slow, not greatly fast, but it was 0.2 layers, and that's the standard nozzle size that comes with the machine. So I'm going to finish setting up Cura, the special version of Cura that's designed for the LulzBot Taz6, and get on with slicing some models and actually testing this machine and its capabilities with different materials and different speeds. I'm quite keen to just see how fast this can go, especially with the deposition rates of the hexagon hot end. My first reaction is to want to put a Volcano with a bigger nozzle size and actually get a lot more fast, high-speed printing out of this. But we'll see how well we get on with the hexagon and then see where we take it from there, because there's definitely room for upgrade changes, all that sort of thing. One very first thing I did was just added a tie wrap around the extruder carriage, and that was really just to hold this wiring loom in place, because that's the only one again on this part of the printer that doesn't have positive locking, and because it's got the motor connections on as well, you don't want that knocking off while the machine's on, because you can damage the motor drivers if you disconnect a motor while it's connected and running. So I've put an extra tie wrap on there, and that just holds it nice and firmly in place, and it's very unlikely that's going to come off. But that's about it. So our little bench is looking quite good. I'm going to let that cool down before I try and take it off the platform. But yeah, that's not a bad start, and I think we're all up and running and no more problems after the fixing of the SD card connector that had fallen off inside. So join me next time and we'll give this TAZ6 a real run through and do some really exciting printing. Okay, see you again next time.